Welcome to Chapter 5, which is going to be trigonometric functions. We're going to be taking a look at the first two sections of Chapter 5 in two separate videos. So in Chapter 5, Section 1, we're going to be talking about angles, and we're going to cover basic terminology, measuring them with degrees, what is a standard position, and coterminal angles. So if we have two distinct points, they would form the line AB. Notice in this line, we have an arrow in both directions. So this is considered a line. A line segment is different in that it has two endpoints. So it has a definite ending point and a definite starting point. A line segment is always named with its endpoints. Then we have array. Array has one starting point, and then it's going to continue forever in one of the two directions. And when that happens, you have to name array using the starting point, but you could use any point after the starting point to name it. An angle is going to consist of two rays because they have a definite starting point and they're intersecting each other and forming an angle. The rays themselves form the sides of the angle, and the endpoint where they intersect is going to be called the vertex. An angle's measure is found by rotating the vertex. So when we say rotating, it might be misleading. Basically, we're measuring how many degrees are between my initial side and my terminal side. If it's a positive angle, the rotation of the terminal side of the angle is going to move counterclockwise. So this is going to be positive. If I'm negative, I'm going to move clockwise. So this could be something like, say, positive 270. And this could be something, say, positive negative 80. So that's what's telling you whether you're going up or whether you're going down, is the positive or negative symbol. The most common unit we're going to use to measure angles is going to be degrees, but it's not the only way. A complete rotation, if you were standing straight up and you went in a circle, so just turn in a circle, that would be 360 degrees, because that's what a full rotation is. That might be familiar because we talk about circles, and circles have 360 degrees, because if you travel in a circle from start to finish, you're going to pass through 360 degrees. Angles are going to be classified using their measures. So acute angles are going to be angles between 0 and 90. Now notice, if it's equal to 90, it's a right angle. It's not acute. If it's greater than 90, but less than 180, it's going to be obtuse. If it's exactly 180, it's going to be what we call a straight angle. So if I want to find the complement and the supplement of an angle, we first need to define what is the complement and what is the supplement. A complement are two angles that are complementary when they add to be 90 degrees. Two angles are supplementary if they add to be 180 degrees. So in example A, if I'm given an angle of 40 degrees and I want to find its complement, two angles have to add to 90 to be complementary. So if I do 90 minus 40, that will tell me the second angle. 40 and 90 do add together to be, 40 and 50 do add together to be 90 degrees. If I want to find the supplement to 40 degrees, supplementary angles are angles that add to be 180 degrees. So I would do 180 minus 40 to get my supplementary angle of 140 degrees. If you add 40 and 140, you're going to get 180. So these questions aren't difficult, but you've really got to focus in on those key terms. You have to know what complementary means, and you have to know what supplementary means. This time, I'm giving you an angle with a variable in it, and I want to find the measure of each individual angle. Well, what I notice here is there's a little box. There's a box here, And if we remember back to our angle information, this box tells me that these two angles combine to be 90 degrees. If they combine to be 90 degrees, then they are complementary. So that means if I add 6x and 3x, they're going to equal to 90. I'm going to combine my like terms and then divide both sides by 9. So they get the measure of x is 10. But that's not the measure of my angle. To find the measure of my angle, I need to actually take that 10 and plug it back in to the equations to get 60 degrees and 30 degrees. Then as a self-check, I could actually go ahead and add those two angles together just to be sure they add to be 90. So if I take 60 and 30 and I add them together, they are equal to 90 degrees. This is a similar question where I'm asking you to find the measure of each angle and they're on a straight line. So if we remember, a straight line angle is going to be 180 degrees. So if two angles are adjacent, which means next to each other, on a straight line, I know that they're going to add to be 180 degrees. So I'm going to take 4x and 6x and add them together to get 10x, and I'm going to set that equal to 180. Then I'm going to solve for x and get 18, but they asked me for the measure of the angle, not for the value of x. And this is a place to be really careful in the math lab, because if you entered x equals 18, your answer would be wrong. You have the right math, but you have the wrong final answer, because you need to plug the 18 in for x to get 72 and 108. Now remember, when I have 72 and 108, if I add those together, they should be 180, and you can use that as a self-check. We have a way of measuring small increments of degree angles. So when a degree has a decimal behind it, that is going to involve what we call minutes and seconds. So a minute is 1/60th of a degree. Should be familiar, right? There's 60 minutes in 1 hour. And a second is 1/60th of a minute. So what we were doing, what these are useful for, is when we have decimal degree amounts, we usually convert them into minutes and seconds to make things more clear for software programs and for applications where we're actually using these angles to do calculations. So if I had 51 degrees and 29 minutes plus 32 degrees and 46 minutes, I'm going to kind of do a separate problem and add the degrees together and then add the minutes together. Because 75 minutes is going to be over a full minute, 60, then I'm going to make that 1 and 15, because if I divide that by 60, it happens once with a remainder of 15. So those two added together are 84 degrees and 15 minutes. If I'm subtracting, it works the same way, but I can't subtract 73 and 12 from 90. So what I'm going to have to do is take that 90 down 1 and think of 90 as 89 degrees in 60 minutes so that I can then do the subtraction. To convert from minutes and seconds to the actual decimal value, you simply take the number of minutes and divide by 60, take the number of seconds and divide by 3,600. Why is it 3,600? Because there are 3,600 seconds in an hour. And here our degree is kind of a whole unit. So this gives me 74.137. These are conversion factors you're going to have to memorize, so you may want to write them down on a sheet of paper. Now if I want to take the actual decimal and I want to convert it, I was doing division here. I'm going to do the inverse and take what's behind the decimal and multiply it by 60. And that gives me 49.02. Then I'm going to take that 0.02 and I'm going to multiply that by 60 and I get 1.2. Then I'm going to round that 1.2. It would round down to 1, and that's how we get there. Notice I don't multiply by 3600 because I'm multiplying by 60 twice, which is the same thing. So what is standard position? The standard position of an angle is when its vertex is at the origin, so right here, which means the initial side of the angle has to be on the positive part of the x-axis. When we deal with quadrants, we deal with what we call quadrant angles. So we have the nice coordinate plane, and we have quadrant 1, 2, 3, and 4. So those angles at 90, 180, 270, and so on, because they're on an axis, are called quadrantal angles because they're directly on an axis. Coterminal angles have an interesting relationship. If you stand in place and you make one complete turn, just quickly on your feet, a complete turn, you traveled 360 degrees. If you make another turn, would your location change? So turn again 360 full degrees, and you should notice you're in the exact same spot. This phenomenon is called coterminal angles because I could have this angle as 60 degrees, but if I turned 360 degrees plus 60, that would be the pink line, and it actually puts me in the exact same location. So the great way to think about this is very similar to reducing fractions. When we're reducing angles, we're subtracting 360 from them. Just like when you reduce a fraction, you're dividing the numerator and the denominator by some factor. So if I have a measure of 908 degrees, the way we can find an angle we can actually do the math with is to subtract 360 until we get a value between 0 and 360. So if I did 908 minus 360, I'm going to get, let's see, they did it a little different in the example. Let's try it. 908 minus 360 is 548. That's not small enough. I need it to be between 0 and 360. So I subtract 360 again, and I get 188. So all we're doing is subtracting 360 until we get a value between 0 and 360, and that is a coterminal angle, which we can actually do something with on the graph. If I want to find a positive coterminal angle, I'm going to add 360 until we get a value between 0 and 360. So if I have this angle negative 75 degrees and I add 360 to it, the coterminal angle is 285 degrees because I've gone and look at it, it's in the exact same place. If I want to find the example of these angles, I can keep adding, or I could do 360 times some value and add it at one time. I don't really recommend using that method. I would take negative 800 and I would add 360, and that would give me 440. Then I would subtract 360 again, and I would get 80 degrees. So I want to make sure that we're subtracting those 360s appropriately to be able to get to that coterminal angle. If I wanted an expression that would give me every single coterminal angle, we do that as n times 360. So you just take the measure of your angle and you would say plus or minus, technically we could have minus, n times 360. So here's a few examples of coterminal angles that are coterminal with 60 degrees. And then our last one is we're looking at the revolution of a CD player. If a CD player spins 480 times per minute, if I wanted to think about how many degrees that it went through, I would multiply 480 times 360. That's massive, right? That's the number of degrees that the CD is actually spinning per minute. If, though, I want to ask a question about it moving in 2 seconds, I'm going to have to equate this to 2 seconds, not to a minute. which is why it goes 480 times in 1 minute, which would be 480 divided by 60 seconds. So when I simplify that, I get 8 times per second. If it's going for 2 seconds, that would be 8 times 2, which is 16 times. So the CD is going to spin around 16 times. If I want to find the degree measure for how many degrees it's spinning through, I would take that 16 and multiply it by 360 so that it spins 5,760 degrees in 2 seconds, which is pretty quick. And that's the end of section 5 with our introduction to angles and measurement. Continue on to the next section for help with that.